Roanoke, Virginia, 2025. The N&W shops stand quiet now, a museum piece where once the thunder of heavy machinery shaped America's most feared locomotives. In the yard behind the Virginia Museum of Transportation, Class Y6B number 2156 sits in silent testimony to an era when sheer brute force ruled the rails. Her massive compound, articulated frame seems almost prehistoric, a mechanical dinosaur that once pulled loads no other engine dared attempt. Step back to 1952, and this same yard pulsed with a different energy. The Norfolk and Western Railway faced an impossible challenge, moving West Virginia's endless coal production across terrain that broke lesser locomotives. The Pocahontas Division demanded power, raw, unrelenting pulling force that could drag 5,000 tons up grades that made other railroads blanch. The Y6B was N&W's answer, and it terrified the very men who operated it. These weren't your typical road locomotives. At over 580,000 pounds, the Y6B compound mallet, articulated configuration, represented the absolute pinnacle of steam locomotive engineering. 24 years after other railroads abandoned steam, Norfolk and Western refined these monsters to perfection. Front and rear engine sets working in tandem could generate starting tractive effort exceeding 152,000 pounds, power that could literally rip couplers from freight cars or pull rails from their ties if mishandled. The whisper started in the engineman's quarters at Williamson and Bluefield. Track foremen reported rail spread after heavy Y6B passages. Maintenance crews found stress fractures in drawbars rated for loads far beyond normal service. Yardmasters watched nervously as these behemoths assembled trains that pushed every safety margin. The Y6B could move mountains of coal, yes, but at what cost to the infrastructure beneath its drivers? Tonight, we'll journey through the coal fields and over the mountain grades where these articulated giants proved both indispensable and dangerous. We'll hear from the engineers who wrestled with throttles connected to more power than they fully trusted, from track supervisors who checked rail after each passage, from brakemen who prayed their couplers would hold. The Y6B wasn't just a locomotive, it was a calculated risk on every run, a machine whose capabilities exceeded the very railroad it served. The story begins not in 1952, but decades earlier when Norfolk and Western first confronted the brutal mathematics of coal transportation. The Pocahontas coal fields of West Virginia held billions of tons of high-grade bituminous coal, but moving it eastward to tidewater ports meant conquering the Appalachian barrier. Grades of 1.2% stretched for miles, inclines that seemed modest on paper but became nightmares under thousands of tons of dead weight. Early compound mallets served adequately through the 1910s and 20s, but traffic demands exploded. By the late 1930s, N&W's engineering department under mechanical Superintendent R.H. Smith faced hard questions. Could they design a locomotive capable of hauling 5,000-ton coal trains unassisted over the ruling grades? The number seemed impossible. Conventional wisdom suggested multiple locomotives or helper service. Smith's team thought differently. The Y-class evolution represented methodical refinement rather than revolutionary innovation. The Y5 and Y6A variants established the basic parameters: simple expansion rear engine for starting power, compound expansion front engine for efficiency at speed, and massive boiler capacity to feed both. But the Y6B, emerging between 1948 and 1952, incorporated lessons from 2 decades of heavy service. Improved superheating, refined valve timing, and, crucially, stronger running gear capable of transmitting unimaginable forces. The first Y6B trials in 1948 shocked even N&W's optimistic engineers. Test Train 151 departed Williamson Yard with 4,800 tons trailing, an unprecedented consist that stretched beyond sight. Engineer Tom Morrison later recalled throttling that first departure with genuine fear. You could feel power building like nothing I'd experienced. The engine seemed to squat down, then just started walking away with that train like it was nothing. But I kept thinking about those poor couplers back there. What Morrison and his contemporaries understood intuitively, N&W's engineering data confirmed through cold mathematics. The Y6B generated starting forces exceeding anything previously placed on commercial rails. Standard knuckle couplers rated for 150,000 pounds operated with minimal safety margin. Rails themselves, particularly on curves, experienced lateral forces approaching their design limits. The Y6B represented the locomotive pushed to its absolute theoretical maximum, beyond which lay only failure. Yet coal traffic demanded these capabilities. Rival Chesapeake and Ohio relied on multiple locomotives or helpers. N&W chose a different path. One locomotive, one crew, maximum tonnage. The economics appeared unassailable. The risks, however, were only beginning to emerge. Bluefield, West Virginia, September 1953. Track supervisor Walter Brennan stood in early morning fog, examining the main line where yesterday's eastbound coal train had passed. The rail gauge looked wrong, widened perhaps an eighth inch beyond specification. He knelt, measuring carefully with his gauge bar. The reading confirmed his suspicion. Number Tunchao 174 had pulled 5,200 tons through here, and the rail had moved. This wasn't isolated. Reports filtered through N&W's maintenance departments with unsettling frequency. Near Eager, a slow order went into effect after inspectors found tie plates shifted on a tight curve, precisely where Y6B locomotives fought maximum loads around mountain shoulders. At Portsmouth Yards, Carmen discovered drawbar cracks on coal hoppers that had been in near-continuous Y6B service. Most telling were the coupler failures, 3 in 1 month during autumn 1953, each on trains exceeding 5,000 tons. The engineering department's response mixed confidence with concern. Chief Mechanical Officer could point to thousands of successful runs, to loaded coal trains delivered on time, to operating costs that justified every risk. Yet he also authorized track reinforcement programs specifically for Y6B routes. Heavier rail went down on curves. Tie replacement accelerated. Coupler inspections became mandatory before every heavy consist assembly. The engine men developed their own culture of caution. At crew change points, departing engineers briefed their replacements with warnings beyond the standard rulebook. Watch your speed through the Merrimack curve. She wants to walk the rail. Don't let her lug on the grade out of Canova. If she stalls, you'll never get moving again without breaking something. This oral tradition acknowledged what company officials preferred not to discuss. The Y6B operated at the absolute edge of safe practice. Frank Webster, a Roanoke-based engineer with 20 years Y6B experience, put it plainly in a 1958 interview. You respect the machine. Every time you notch that throttle with 5,000 tons trailing, you're asking steel and iron to do things they weren't quite meant to do. She'll do it, Lord knows she'll do it, but you're always aware something could let go. Rail, coupler, even her own running gear if you're not careful. It's like handling dynamite. Powerful, useful, and dangerous if you're careless. The statistical reality supported Webster's caution. Y6B locomotives compiled remarkable service records, yet their accident rates, minor derailments, coupler failures, damaged infrastructure, exceeded other locomotive classes per 1,000 miles operated. The power came with a price, paid in heightened vigilance and occasional failures. Our journey follows the iron path these giants traverse daily. From the grimy coal tipples of Williamson to the sprawling classification yards at Portsmouth, Ohio, the Y6B's domain stretched across the most challenging railroad territory in the East. Each route segment presented unique dangers that multiplied under maximum tonnage. The Pocahontas Division main line westbound featured extended ascending grades where Y6B power proved essential. Leaving Portsmouth with empty hoppers, the locomotives ran light, almost playful compared to their typical service. But marshalling at Williamson or Canova transformed them into laboring monsters. 5,000 tons of West Virginia coal converted nimble runners into plodding behemoths, generating forces that stressed every component. Engineer James Mitchell recalled his first heavy run from Williamson in 1954. They gave me 2165 with 135 loads, about 5,150 tons as I figured it. The yardmaster just looked at me and said, "She'll handle it, but keep her moving." Getting that train started felt like trying to move a building. You ease the throttle, hear the cylinders start working, and for a moment nothing happens. Then she digs in, and you feel every one of those 152,000 pounds of tractive effort going through the frame. The whole locomotive shudders, and you hope everything holds. Certain locations acquired legendary status among crews. The curve at Merrimack presented a tight radius where centrifugal force combined with drawbar pull created maximum lateral stress. Track supervisors walked this section after every heavy train, checking for rail creep and tie displacement. The grade east of Eager, 1.2% for 5 continuous miles, became the proving ground where Y6B capabilities were demonstrated daily. Ascending with 5,000 tons, these locomotives worked at their absolute maximum for sustained periods exceeding 30 minutes. Downgrade operations presented different terrors. The air brake systems rated for such tonnage barely existed. Descending toward Portsmouth, engineers relied on locomotive brakes and careful throttle management, using the engine itself as a brake through compression. Runaway fears haunted every descent. A Y6B with 5,000 tons accelerating, beyond control, represented catastrophe. Brakes would fade, couplers would fail from buffing forces, and derailment became inevitable. Weather complicated everything. Winter operations saw slip and slide as massive drivers fought for adhesion on frosted rails. Summer heat expanded rails, narrowing the margin between safe operation and rail spread under extreme lateral forces. Rain made grades treacherous. Crews learned to read conditions, adjusting tonnage ratings down when circumstances demanded, but traffic pressures constantly pushed against conservative judgment. The Y6B routes carved permanent memories in those who worked them. These weren't merely railroad lines, but proving grounds where man and machine tested limits daily. Inside the cab of number 2190, departing Williamson on a February morning in 1957, the reality of Y6B operation became immediately visceral. Engineer Robert Patterson and fireman Dale Cooper faced a dashboard of gauges monitoring forces barely contained. Steam pressure, 300 pounds per square inch. Water level, 3/4. Temperature, optimal. Behind them stretched 142 loaded hoppers, 5,280 tons by the car list. Patterson's routine followed protocols developed through hard experience. You don't just open the throttle on a Y6B, he explained to Cooper, who was training for promotion. You coax her. Watch the steam chest pressure, listen to the exhaust, feel the feedback through the throttle bar. She'll tell you when she's ready to move that load, force it, and you'll break something, guaranteed. The departure sequence took 3 minutes. Gradual throttle advancement allowed slack to stretch gradually through the entire train. Too rapid acceleration would snatch couplers. Several failures had resulted from impatient engineers jerking heavy trains into motion. Patterson nursed the throttle to the first notch, held steady, then advanced again. The compound articulation meant front and rear engines worked at different pressures. Coordination required experience and feel. Coal trains weren't all the Y6B hauled, though coal defined their purpose. Occasional merchandise drags, helper service on passenger extras, even wartime troop movements saw Y6B deployment. Each service revealed different characteristics. Light trains let crews experience the surprising speed these locomotives could achieve. 60 mph wasn't uncommon with reduced tonnage, though it felt reckless given their massive proportions. Maintenance crews told different stories. At Schaffer's Crossing back shops, Mechanical Inspector Arnold Hayes supervised Y6B heavy repairs. The running gear takes a pounding like nothing else, Hayes noted while examining worn driver journals. We'd see metal, fatigue in places that should last years. The forces going through these machines exceed their design parameters on every heavy run. We're constantly replacing parts that theoretical engineering said would hold up fine. Theory meets reality in the shop. The fireman's role proved particularly demanding. Feeding a Y6B's massive firebox required continuous effort, particularly on grades. Cooper shoveled coal with methodical rhythm, maintaining even heat across the grate. Poor firing meant pressure drop, which meant power loss, potentially stalling mid-grade with disastrous consequences. A stalled Y6B with 5,000 tons on ascending grade created nightmares. Restarting risked coupler failure, while standing meant blocking the main line. Brotherhood of Locomotive Engineers meetings featured recurring Y6B discussions. Safety representatives documented concerns about operating practices that pushed limits. Management countered with operational necessity and economic requirements. The tension, never resolved, it simply became part of Y6B culture. Respect mixed with apprehension, pride, combined with caution, and everyone understood they operated at railroad engineering's absolute frontier. The proving runs came in 1955 when Norfolk and Western management decided to definitively establish Y6B capabilities. Test Train 172, assembled at Williamson on June 14th, consisted of 147 loaded hoppers, an almost unthinkable 5,612 tons. Engineer Harvey Johnson drew the assignment with a gallery of company officials and mechanical engineers occupying the cab and a following inspection special. Johnson later described the departure as the most nerve-wracking moment of my career. With company brass watching, he brought train 172 out of Williamson Yard and onto the main line ascending grade. The dynamometer car registered starting tractive effort at 148,200 pounds, near theoretical maximum. The train moved, slowly but decisively. For 15 miles, number 2291 hauled this extraordinary. Load up a continuous 1.2% grade, maintaining 8/12 throughout. The test succeeded, but inspectors found troubling evidence afterward. Rail gauges on curves showed widening approaching limits. Two couplers displayed hairline cracks. Most significantly, metallurgical analysis of 2191's running gear revealed stress levels in the danger zone, not immediate failure, but shortened service life. The Y6B could handle 5,600 tons, but regular operation at such tonnage would destroy locomotives and infrastructure alike. This established working parameters still in use when steam ended. Maximum rated tonnage settled at 5,000 tons with favorable conditions, reduced to 4,200 tons in adverse weather. The numbers appeared arbitrary to outsiders but represented careful calculation, balancing operational needs against equipment longevity and safety margins. Daily operations proved these calculations sound. Through the late 1950s, Y6B locomotives moved millions of tons of coal with remarkable reliability. Serious failures remained rare. Minor incidents became accepted operational costs. The economics remained compelling. One locomotive and crew replacing multiple units or helper service justified heightened maintenance and occasional infrastructure damage. Rival railroads watched with interest and concern. Chesapeake and Ohio stuck with their multi-locomotive approach. Virginian Railway briefly experimented with similar high-tonnage single locomotive operation, but retreated after coupler failures. Only Norfolk and Western possessed the institutional knowledge, maintenance capability, and operational culture to make Y6B operations successful. By 1960, the fleet of 36 Y6B locomotives handled the majority of N&W's heavy coal movements. They'd become indispensable despite their demands and dangers. Crews who mastered them gained legendary status. Supervisors who kept them running earned respect throughout the industry. The Y6B represented American railroading's final flowering. Before dieselization, maximum capability extracted from steam technology through engineering excellence and operational courage. The end came not from failure, but obsolescence. Through the early 1960s, Norfolk and Western maintained steam operations while other roads fully dieselized. Economic analysis showed Y6B locomotives remained cost-effective given cheap coal and mature maintenance practices. But parts availability declined as suppliers exited the steam business. Labor costs rose. Most critically, operational flexibility favored diesels that could be combined in multiple units without the single-point vulnerabilities of individual steam locomotives. The last revenue Y6B run occurred in May 1960, when number 297 hauled a 4,800-ton coal train from Williamson to Portsmouth. Engineer Thomas Bradford made that final trip, his career having begun in the steam era and now transitioning into diesel dominance. "She handled that load beautifully, just like always," Bradford recalled decades later. "I remember thinking how sad it was. We'd finally perfected these machines, learned to use their power safely, and now we were walking away from them." Scrapping began immediately. Of 36 Y6B locomotives built, only 256 survived, preserved at the Virginia Museum of Transportation in Roanoke. The rest went to scrappers' torches, their massive frames and machinery reduced to ingots. The tracks they stressed remained in service, indeed remained in service today, now handling loads the Y6B engineers would find astounding. Modern coal trains exceed 15,000 tons, pulled by multiple diesel-electric locomotives whose combined power exceeds the Y6B, but distributes forces across multiple units. The preservation of 2156 ensures the Y6B story continues. Museum visitors can walk around this massive machine, examining the compound articulation, the enormous drivers, the cab where engineers wrestled with more power than they fully trusted. Interpretive displays explain the technical details but struggle to convey the operational reality. The fear and respect, the constant vigilance, the awareness of operating at the absolute edge. Modern railroad engineering looks back at the Y6B era with mixed assessment. The locomotives proved that steam technology could achieve extraordinary power levels. They also demonstrated why such extreme single-unit power proved unsustainable. Infrastructure costs, maintenance demands, and operational limitations simply overwhelmed the economics. Yet for a brief period, the Y6B represented the absolute pinnacle of what could be achieved with fire, water, and steel. The engineers who feared them have mostly passed now. Their oral history, preserved in archives and railroad historical societies, tells of machines that demanded respect every moment. The Y6B wasn't just a locomotive. It was a daily confrontation with physical limits, a test of nerves and judgment, and ultimately a reminder that some capabilities come with prices not entirely measurable in dollars. Standing beside Ton 156 today, one can still sense the power that made strong men cautious. The massive frame, the huge drivers, the complex articulation all speak to forces barely contained. The 5,000-ton promise was kept thousands of times through years of operation. That it came with fear makes the achievement more, not less, impressive. Portsmouth, Ohio, present day. The Norfolk and Western's once mighty classification yard has transformed beyond recognition. Where Y6B locomotives once assembled impossible coal trains, intermodal containers stack high awaiting modern diesel power. Yet something lingers here. Ask the veteran railroaders gathering at the local museum, and you'll hear stories passed down like folklore. Charlie Morrison, grandson of engineer Tom Morrison, who ran the first Y6B test train, works as a track supervisor for today's Norfolk Southern. He walks the same routes his grandfather traversed, now handling trains triple the Y6B's tonnage with distributed power units. Grandpa's old logbooks are still in our family, Charlie explains, flipping through the water-stained pages documenting every Y6B run from 1948 to 1959. He recorded everything: tonnage, weather, track conditions, close calls. There's an entry from August 1953. Made Williamson to Portsmouth with 5,150 tons. Felt coupler slip at milepost 47. Praise God it held. That one line tells you everything about what those men lived through. The engineering data tells parallel stories. Norfolk Southern's historical archives contain stress analysis reports from the Y6B era that modern engineers find shocking. Dr. Patricia Chen, a railway mechanical engineer reviewing these documents for academic research, discovered calculated safety factors that would never pass contemporary standards. They were operating with margins of 10 to 15% on critical components, Chen notes with academic astonishment. Today we demand 50% minimums. The Y6B program succeeded through vigilance and luck as much as engineering excellence. But perhaps the most haunting testimonies come from the maintenance workers who kept these machines running. Henry Blackwell, now 92, worked at Schaffer's Crossing shops from 1952 until dieselization. His memories remain crystalline. Every Y6B that came through for heavy maintenance had stories written in the metal. Stress cracks in places that shouldn't crack, wear patterns that defy predictions. We'd fix them, send them back out, and pray. Those locomotives were magnificent and terrifying in equal measure. I loved them and feared them both. The coal still moves through these routes, more than ever, in fact. Modern unit trains with distributed power eliminate the single-point vulnerabilities that made Y6B operation so nerve-wracking. Yet something was lost in that transition. The men who mastered those powerful, dangerous machines possessed skills and courage that can't quite translate to today's computer-monitored multiple-unit diesel operations. At Roanoke, Number 2156 stands in silent testimony, her massive frame and compound, articulation explaining more than words ever could. Museum director James Patterson, no relation to engineer Robert Patterson, sees visitors react physically to the locomotive's presence. They step back when they first see her. Even static and cold, she radiates power and danger. That's the Y6B legacy, not just what she could do, but what men had to overcome within themselves to do it. The 5,000-ton promise was kept thousands of times by men who respected and feared the machines they commanded. Their achievement stands not despite that fear, but because of it, because they understood the forces they controlled and never grew complacent. In an age of automation and safety systems, the Y6B era reminds us that some accomplishments require confronting dangers directly with nothing but skill, judgment, and courage between success and catastrophe.